This lectures cover the applications of functions in business. Our main objective is to learn how to formulate and evaluate the total cost, total revenue, and profit functions. We're also going to learn how to find the marginal cost, revenue, profit, given the linear total cost, total revenue, and profit functions. So let's start with the first example. Suppose a firm manufactures MP3 players and sells them for $50 each. The costs incurred in the production and sale of the MP3 players are $200,000 plus $10 for each player produced and sold. Write the profit function for the production and sale of S players. So we know the profit function will give us the difference between the revenue function and the total cost function. So the revenue, since the company sell each MP3 for $50, then the revenue will be 50. Let's say X represents MP3, the number of MP3s sold or sell. So revenue will be 50X. That will be the revenue function. Then we know total cost will be the fixed cost plus the variable cost. The fixed cost is $200,000 and the variable cost will be $10. So it will be 10X. Why? Because the question said 10 for each player produced and sold, the cost. So this means profit function will be the difference between, again, the revenue and the total cost. So let's see the steps. The total revenue, again, is S MP3 players is 50X. So R at X equal to 50X. And then we say the fixed cost is 200,000. The total cost for X players is then 10X plus 200,000. So the difference of the two will give us the profit. So P at X equal to R at X minus C at X. And that will give us 50X minus 10X plus 200,000. That's the total cost function. So the final we get 40X minus 200,000. Now we know a profit a firm makes on products, as we see the first example, is always the difference between the amount the company generated or the revenue minus the total cost. So P at S always is R at X minus C at X. P at S again represents profit from sale of S unit. R at X represents total revenue from sale of X unit. And C at S is the total cost of production and sale of X unit. Now, in general, we say the revenue is found by using the equation. The revenue, price per unit times number of units. As we saw the first example, price per unit is $50. Number of units is X, so it's 50X. Now, total cost will be the fixed cost plus the variable cost. So that's the formula given. Now, in example one, we saw both the total revenue function and the total cost function are linear. So their difference, the profit function, is also linear. So in this case, the slope of the profit function will represent the rate of change in profit with respect to what the number of units produced and sold. So this is called the marginal profit. So anytime we hear the concept of marginal and in the linear equation, then our mind will come to, again, slope. So in example one, as we saw in the function 40x, so the slope is 40. We can go back to the function and make sure. So if we have our profit function is 40x minus 200,000, then the marginal profit is the slope, which will be 40. So that's how we find the marginal concept. So we say similarly, the marginal cost also the same for this product is $10 because we have 10x plus 200,000. So the marginal cost, total cost is 10x plus 200,000. That's from the example one. So this means the marginal cost will be $10. Same thing with the revenue. Revenue was 50x. So the marginal revenue will be 50 from the first example. Now we have a second example here. So they say, suppose that the cost in dollars for a product is given as C equal to 21.75x plus 48.90. What is the marginal cost for this product? The marginal cost for this product will be 21.75x. And what does it mean? It's the slope of the equation. So here we say the equation has a form C equal to MS plus B. So the slope is 21.75, and that's the marginal cost. So because the marginal cost is the slope of the cost line, we say that the production of each additional unit will cost 21.75. Remember, the total cost function is 10s plus 200,000. What the term is, it means that each item we produce, it will cost additional $10, and that's the slope. So now let's go to the last concept, which is the break-even analysis. Now, in business application, anytime we sell a product or we do business and the profit is equal to the zero, which means the total cost and total revenue are the same, we say it's an break-even point. So break-even point, the profit is zero. Company doesn't make no profit, and company don't make no loss. They don't lose. So here we say we can solve the equation for total revenue and total cost simultaneously to find the keyword here is simultaneously, which means we can equate total revenue equal to total cost. If we know the total revenue function and we know the total cost function, we just say total revenue equal to total cost, then we find the break-even point. So let's see one example here. Here we say a manufacturer sells a product for $10 per unit. The manufacturer's variable cost is $250 per unit, and the cost of 100 units is $14.50. So here we should be very careful. This is not a fixed cost. They say the cost of 100 units is $14.50. And also variable cost is this value. How many units must the manufacturer produce each month to break even? So we just have to say, okay, the total revenue for X unit of product is 10X because $10 per unit. X is the number of units. But when it comes to the equation for the total cost, now instead of saying C equal to the fixed cost plus the variable cost, here we have to be careful because the $14.50 represents the 100 units cost. When a company produces 100 units, it costs $14.50. So here we don't have no fixed cost. So here we can say C minus $14.50 equal to 2.5 times X minus 2.5 times 100. So this means our fixed cost will be 1,200. Why is it minus? Because we saw that 100 units produced gave us $14.50. But we want to apply this $250 for every, so it will be again, when we multiply 2.5 by X and 2.5 by 100, and we had it because the $14.50 cross the equal sign, and this is negative value here. So again, we are going to get 250 negative and 1450 positive. So it will be 1450 minus 250, that gives us 1200. So now we know the total cost, we know the total revenue. So to find the break-even point, we say R equal to C, total revenue equal to total cost. So that gives us 10X equal to 2.5X plus 1200. So we solve for X. X gives us 160. So this means in order to get a break-even point, the company have to, again, the manufacturer will break even if 160 units are produced per month. So again, break even means no profit, no loss. So that's why revenue equal to the total revenue equal to the total cost. So that's the graph we're trying to explain. So you can see this graph here. Above is profit region, below is loss region. So the question we have C equal to 2.5, 50S plus 1200. That's the cost line equation. And the revenue is 10X. So if we say 10S equal to 2.50S plus 1200, we will get this point of solution. So any value below will be the loss region, above will be the profit region. So that will be the conclusion of these lectures. Again, wish everybody the best. So next week, we are moving to quadratic equation, which will be chapter 3 of the course textbook.